Welcome to Parabolas. Okay, so let's try to define what a parabola is. A parabola consists of all points that are the same distance from a given fixed point and a given fixed line. And that's pretty wordy. Just kind of bear with me for a little while, and we're going to see if we can break that down. The fixed point is called the focus, and the fixed line is called the directrix. The vertex is the midway point between the focus and the directrix. And I've used Desmos to pull open a parabola. And we're defining, I've added the directrix and the axis of symmetry and the focus here. Okay, so the part of the definition where it says all points that are the same distance from a given fixed point and a given fixed line. So the fixed point is the focus and the fixed line is the directrix. So if we draw lines from the directrix to the parabola, that distance, for example, R to P, should be the exact same distance from P to F. Same with S to V, and then V to F. Also T to Q and Q to F. So all those distances from those points to point, from the fixed line to the parabola, and then from the parabola to the focus, those distances should be the same. So let's reread that. Parabola consists of all points that are the same distance from a given fixed point and a given fixed line. So again, the fixed point is called the focus, and the fixed line is called the directrix. The vertex is midway between the focus and the directrix. And here's the standard form equation for a parabola. There ends up being two. So we've got x squared equals 4py and y squared equals 4px. And using Desmos, we can see if we've got the x squared equals 4py, where p is a positive number, we get a parabola that is opening towards the positive y. And here we've got x squared equals 4py, where p is a negative number. We get the parabola opening towards the negative y. And we observe here where we've got y squared equals 4px, where p is positive. We get a parabola that is opening positive x. And here again, we've got y squared equals 4px, where p is negative. We can see the parabola is opening to the negative x. Okay, so let's work an example. Example 1 states we're going to find the equation of the parabola with a focus at 3, 0 and a directrix at x equals -3. So the first step is to plot the focus. And we've got x is equal to 3 while y is equal to 0, so we can plot that dot right there. Next, let's plot the directrix at x equals -3. And so we've got on the x-axis, we're going to go back 1, 2, 3. There's -3 and draw that line. So with the focus and the directrix plotted, now we know where the vertex is. It's right in between those 2 points. And so we can find P in the standard equation. P is equal to the distance from the vertex to the focus. So in this case, P is positive, going positive on the x-axis. So P is equal to 3. We also know that the parabola is opening to the positive x-axis. So again, to finish up example 1, we know that the focus was at 3, 0, and the directrix was at -3, x equals -3. We solve for p. P was a positive 3. That gives us our final equation, y squared equals 12x. And if we put that into Desmos, we can see the parabola. All right, so example 2, find the focus and equation of the directrix of the parabola y squared equals 24x. So we've got y squared equals 24x. We're going to divide out the 4 to get it into our standard formula, and that gives us y squared equals 4px. So the 6 equals the p. We know that the focus now is at 6, 0, and that means that the directrix is at -6 and the vertex is at 0, 0. Okay, so example 3, we've got find the equation of the parabola with the focus at -2, 0 and the directrix at x equals 2. So if we draw in our directrix and our focus, we can see that this parabola is going to need to open to the -x. So that gives us y squared equals 4px. P is the distance from the vertex to the focus. We've got a -2 in this case. And y, so we can now solve our final equation is y squared equals -8x with a vertex that's at 0, 0. Right, this is another similar problem. We've got the focus at 0, 3, the directrix at y equals -3. So if we plot those two, we plot the focus and the directrix, we can see that the parabola needs to be opening up. And so we're opening y, so that's an x squared formula. So we've got x squared equals 4py. We're opening in the positive direction. So the distance from the vertex to the focus is a +3. So we end up with the equation x squared equals 12y. So we're really just dialing in our process here. A lot of these examples are very similar, but it's more about the mechanics and working through the process and building that skill set. So the first step, again, is to plot that focus 0, -1, and then plot the directrix at y equals -1, and we can see that the parabola is opening towards the -y, so that's going to give us an x squared equals 4py, and it's the distance from the vertex to the focus is p, so we've got a -1 there, and we end up with x squared equals -4y. So here we're going to change it up a little bit. We're going to give the formula for the parabola, y squared equals 20x, and we can plot that and see what that looks like. Just drop that straight into Desmos. But what we want to do is work backwards and figure out what the focus and the directrix is at, where those two components are at. So we see that we've got the y squared formula. So we know that it should be, the parabola should be opening x, and because this 20 here is positive, it should be opening towards the positive x-axis. And if we look at our original y squared equals 4px, and we want to solve for p, we know that we have to divide a 4 out of this 20, so that leaves us with y squared equals 4, 5x, where p is equal to 5. So from there we know that P is the distance from the vertex to the focus. So because there's no H and K components in this formula, and we're going to get to those a little bit later on in the slide, because there's no H and K, we know that the vertex is at 0, 0. So therefore we know that the focus, if P is equal to 5, the focus is equal to 5, 0 for this parabola. And if the focus is at 5, 0, the directrix has to be y or x equals -5. So here's a graphical representation, kind of a review of what we've been going over, showing the two different formulas, x squared formula and the y squared formula, how it opens, and how it opens in relation to a plus p or a negative p.